So next is about speeding. For the speeding, we will use the speed radar gun in order to capture the speed of incoming vehicle. And for the result of spot speed study by the radar gun, and we can obtain that the highest speed class is between the 25 to 30 km per hour, and the arithmetic mean speed is about the 23.7 km per hour, which is slightly below than the average speed, the requirement in the UITM, which is 25 km per hour. So there is a slightly problem with the area, which is the small and unclear speed limits assigned a lot create uncertainty for the driver who may intentionally exceed the safe speed. So this poses a significant risk, which is particularly the nearby junction or the bus stop. Without a clear signage, the driver will lack of guideline, which appropriate speed and increasing the likelihood of accident and hazardous situation. So, in order to address this issue, installing the highly visible speed limit signage, like in the picture, will assignly and will remain alert and cautious to the driver. Additionally, the signage will help to reduce the risk of accident near the junction and bus stop by providing clear and consistent speed regulation. This proactive measure will enhance overall road safety and improve the traffic flow.
We will examine the College Perindu Junction through geometry layout. The apparatus used for this lab work are stopwatch, counter, and datasheet. By using this junction capacity study procedures, we begin with safety briefings and equipment checks, including stopwatches and traffic counters. The observation points near College Perindu gave us a clear view of all movements, level V1 through V6 for systematic tracking. For 30 minutes, we recorded vehicles in 5-minute intervals, categorizing them as motorcycles, cars, or heavy vehicles. The structured approach ensured reliable data for our analysis. There are few problems and mitigations that stood out during our survey. We measured the distance between each road and we obtained 7.02 meter to the College de Lima entrance, 6.08 meter to the College Perindu entrance, and 7.12 meter along the Masjid Greatham Road. Hence, the problems are first, the 7.1 meter wide corners force large vehicles like buses to swing into adjacent lanes. It can cause a clear collision risk. Second, faded road markings confuse drivers, especially during peak hours. Third, crosswalks placed too close to the intersection create conflicts between turning vehicles and pedestrians. Lastly, the junction has two entrances and exit, make it confused for the drivers. Hence, our proposed fixes: widen curves to 8.5 meters for smoother turns, repaint markings with retro-reflective thermoplastic for day and night visibility, relocate crosswalks 25 meters back, enable the drivers more reaction time, and merge the lanes into single lane to avoid confusion. These are the data collected. For example, for the right turns from the major road, the conflicting traffic volume is 198 vehicles per hour. The critical gap is 3.3, and the result for potential capacity is 1,935.96 passenger car units per hour with only 7.08 seconds delay. It's earning a level of service A rating. This means the junction currently handles right turns efficiently, but geometric improvements will make them safer too.
Next, for visual aid, the first major issue is faded or missing road markings. As you can see, the lane lines and guides have faded, making them unclear for drivers and pedestrians alike. This can lead to confusion during peak traffic hours, especially in poor weather conditions. Secondly, we observe poor placement of pedestrian signage at the junction. The signs are either not visible or are positioned too far from where pedestrians actually cross, reducing their effectiveness in warning drivers. To address the faded markings, we propose scheduled repainting every 6 to 12 months. This ensures road users consistently receive clear visual cues, which is critical for both safety and traffic flow. Additionally, the installation of yellow blocks at the center of the junction will prevent vehicles from blocking the intersection, especially during heavy congestion. This also increases drivers' awareness of key movement zones.
Go to the roadside safety feature. At this junction, there is no road safety barrier along the pedestrian walkway. This situation poses a serious risk to both pedestrians and vehicles, especially at curve or junction areas where drivers are more likely to lose control. Without a barrier, there is a high chance that a vehicle could leave the road and fall off the edge, which may also endanger pedestrians nearby. Another problem is the difficulty for pedestrians, particularly university students, to cross the road safely due to lack of designated crossing point. To improve the safety, it is recommended to install roadside barriers such as guardrails or bollards to act as a physical block that prevent both pedestrians and vehicles from falling. Additionally, placing a zebra crossing in suitable location can help ensure safer pedestrian movement, especially in areas frequently used by the students. Go to the roadside safety feature. At this junction, there is no road safety barrier along the pedestrian walkway. This situation poses a serious risk to both pedestrians and vehicles, especially at curve or junction areas where.
Today, we will examine the lighting challenges at this junction and present actionable solutions. Our audit revealed 3 key lighting issues. First, overgrown tree branches are creating dangerous shadows by blocking street lights. For instance, imagine students crossing these dark patches at night. Second, inconsistent pole placement leaves gaps in which some are spaced too far apart while others are too short to properly illuminate the road. Third, we found severe uneven lighting. Bright poles directly under poles contrast with dangerously dark zones in between, creating what we call the tunnel vision effect for drivers. The good news, these problems have proven solutions. First, we recommend quarterly vegetation trimming. It is a simple but effective measure to ensure lights can properly reach the roadway. Second, strategic infrastructure upgrades by adjusting pole heights to 6 to 8 meters and maintaining 20 to 30 meters spacing with uniform illumination. Third, for immediate improvement, we propose retro-reflective road markings and zebra crossings. This bounce headlights back to the drivers, compensating for any remaining lighting gaps.
As for landscaping, there is limited sight distance for drivers due to overgrown bushes around the junction. This obstructs the line of vision, especially for drivers turning or merging. Secondly, a promotional banner placed right at the junction corner further restricts the driver's field of view, compounding the risk of accidents. To resolve this, the landscape should be relocated to a less obstructive area, ensuring the bushes does not block visibility. Secondly, bushes near the junction need to be regularly trimmed to maintain clear sight lines. This simple maintenance can drastically reduce the risk of accident.
Last but not least, we need to consider the road surface elements for road design safety. At this junction, the road surface shows signs of edge erosion and cracking, particularly along the white line adjacent to the concrete curb. This issue is likely caused by inadequate drainage or construction. Loose stones in this crack can become a hazard for pedestrians and cause instability for motorcyclists. Additionally, some sections of the road show signs of poor patching, where previous repairs were uneven and not properly completed. This results in surface bump and increase the risk of accidents. So, to address these issues, the cracks should be sealed and the road edge repaired to ensure a smooth and stable surface. For areas with poor patching, a tack coat should be applied before resurfacing, followed by proper compaction to increase subgrade stability and surface strength, ensure long-lasting and safer road conditions for all users.